So here's a brief history of design automation. Everything works with repetition. Before we can start talking about automation, we first need to talk about repetition. And there are two things which are really weird with this picture. One is only dudes working in a very large landscape, and another thing is that everything is analog, so you don't see any computers. A lot of repetitive work is going on here. So they're drawing on papers, and you can just imagine if something goes wrong, then it's a lot of hassle to correcting it. In the worst case scenario, you have to restart. And even worse, if the design is completely changed, well, all of these dudes have to start over. A genius called Evan Sutherland, one of the forefathers of CAD, just at the same time that these guys were slaving away, a PhD student started to experimenting with digital drawing boards. This is the pre-CAD, you could say. Completely revolutionized how engineering is done. And I would say that the thinking of Evan Sutherland is just iterated to what we have today. So what we have today is a more awesome version of what he proposed back in the 50s or 60s. And what we have today is just a more complex version of that. But what he did actually helped us to come to this point. So now we can do all type of engineering and analysis in the computer just because we have this digital model. So you might think, well, that's great. Then what is it more to do? The problem is, it started really, really good, but then when complexity started to increase, then these digital tools really weren't that great anymore. So one example which I really like to show is example with two aircrafts for their times, disruptive technologies, Boeing 747 and Airbus A380. So when they were first ordered and delivered, for Boeing 747, it took 2 years with analog design tools, and for Airbus A380 was more like 10 years, which is very, very weird. So why is that? Because, well, really nothing has changed. So instead of a lot of drawing boards, we have a lot of computers. Everything is digital, but everything is still quite repetitive. That is the problem. So we have a lot of engineers involved in the design. It's very time-consuming and complex. It needs many iterations. The lead times are really slow. There are too many processes going on in parallel. And then we have a lot of mistakes as well. So what we address in product modeling is that 80% of the engineering operations are actually repetitive and routine-like. One example is if you want to take one type of component and then analyze it from the CAD model to the finished analysis in FEM, for example. You need to do a lot of preparations with the geometry. So you need to simplify the geometry in order to make it mesh friendly. Then you need to mesh it. That is also a quite complex process. Then you need to analyze it, and then it's a synthesis afterwards. Anytime in this process, you may need to go back and change something. This can take weeks. So from an idea and execution of a mechanical engineer to the actual result, it takes weeks. And this is really time consuming. As I said, I'm a huge Matrix fan, and if you've seen this movie, you can one of the protagonists of that movie is called Agent Smith, and one of his famous lines is to never send a human to do a machine's job. This is when Cypher failed to terminate the main character Neo because he was so busy with his monologue. So the thing is, in production, there's no doubt that you need to have some type of a tool, for example, an industrial robot, in order to automate some specific type of process. This thinking, definitely for 10 years ago when we started this course, it was like completely like, why? You don't automate anything, just do it manually. That's how everything has always been. So why should we change that? Now there are beginning to be a lot of changes. I see a lot of companies really wanting to do design automation and implementing design automation. So a really big change is coming, and soon maybe this should be a fundamental knowledge to have even. So it's not even an advanced course anymore, but fundamental course. But it's happening a lot of changes. So we want to automate things which is not good for a human to perform. That is specifically something which is repetitive and time consuming. So when we create our design automation tools, basically what we do is that we empower the engineers and make sure that they can become more creative and intuitive by not focusing on the 80% repetitive and routine-like operations. And then, yes, we eliminate the repetitive and engineering work with design automation. The goals of this course is that you will be able to create CAD models of complex products. You will be able to create flexible and reusable CAD models in CATIA V5. And these aircraft shapes that you can see in this slide are actually one and the same model. But with the help of design automation and parametric design, you can just change some parameters and then they can change shape and configuration. We will use a lot of programming in this course. So now I don't have my audience to ask if that is something that you like to do or if it's something that you really don't like to do. My experience is that those of you who love programming, well, this is clearly something for you. Those of you who are hesitant, if you like the vision, if you like the idea of automating what is boring and repetitive, then you will love to appreciate this. You will appreciate this technique because it will empower you in your work. I personally, honestly, when I was studying, there were two things that I really hated. One of them was CAD, the other was programming. So it's irony that I'm doing what I'm doing right now. So I do a lot of CAD and I do a lot of programming. And really, what made me flip my opinion was that I got a thesis where I needed to automate specific processes within aircraft design in order to do aerodynamic analysis. And after that I was completely hooked. So then programming suddenly became fun. So hopefully a lot of students have had this journey, and I hope if you're that student who don't like programming, after this course you will change your mind. Another thing that we will do is that we're going to work with APIs, application programming interface, in order to connect different softwares together. And this is a trial and error process to create models and frameworks. And if the y-axis represents the objectives that you have for your model, there's a high chance that after a couple of objectives you will fail, and then you have to restart. Maybe you even have to throw out the old model and then start from the beginning. This is not something which is out of the ordinary. That's how it is. So don't get too sad if this happens to you. It happens to everyone, and it's how it should be.